How's it, Jordan here? In this video, I'm going to be showcasing my algorithm I made, marching squares.
What do you mean you made it? You didn't make a marching squares. That's an algorithm that's online, right?
Yes, I didn't just steal it from GitHub. Totally not. No, I didn't. But it was quite a fun project actually, making marching squares. It's very cool looking.
Okay, but now explain to me because I'm in
So, marching squares is a cool algorithm that allows fully destructible 2D worlds without using blocky voxels. Although it is a bit blocky.
Okay, what other use cases do you use marching squares? You say it's an algorithm here, okay.
Yes, it's useful for a lot of games, any 2D games you might want.
What else do they use it for?
I think some medical stuff for displaying certain 2D graphs. I'm not sure.
Geographical stuff, maybe?
I think
map
so,
building?
but I think they might use a more advanced marching squares algorithm that
Maybe
uses
marching
weights.
cubes, perhaps.
Maybe, yes. I should make that algorithm. That'd be really cool.
So you wanted to demonstrate marching squares in this game. I see. Is this the actual game you generated? How many lines of code is this?
About 320, I believe.
Okay, and looks quite good. Wow. Very boring, but I'm sure for 300 lines of code, it's pretty good. So use this algorithm. You create this cave system, right?
Yeah, you can create in me an ant colony game or whatever you want. You can place blocks with different colors.
Okay, that's interesting. You had a grid on it once, I saw earlier.
Yes. I don't know where it's disappeared. I can add it back though.
That's fine.
So basically that grid my dad's talking about is just a... this is my dad, by the way. The grid is just just enabling outlines on all these little objects. All these little objects are individual objects. I don't like it much, but it's just how I did it so far. But it does allow you to add little white lines around it, which really does show all the little grid items, how it's on a grid.
So what you could do is you could create a little man that maybe goes around and does his own mining, perhaps in the silly. I said Freudian slip there. A silly little game.
Yes. I could make a more advanced version of Dig-a-Dug instead of, I believe, Dig-Dug uses presets.
That could be quite good. You could have a dog digging.
Yes. Yeah, maybe.
You sound tired, by the way. You're slurring your words. Lots of Freudian slips from me too.
But yeah, instead of having such preset levels that Dig-Dug has, you have more control. You can mine, let's say, full worlds. Be quite cool.
Yeah, that is very interesting. So it's a very, very simple demonstration of the algorithm, which is very cool. And you're going to showcase, or you're going to show people how to do it. It's also going to be on GitHub, hopefully.
Well, I don't know if I'll showcase the code there. Later in the video, I'm going to showcase the full code and how it works.
Okay.
Well, most of the code.
Okay, so it's a really cool idea how to actually show the algorithm, because algorithms by themselves, when someone says algorithm, I feel like I just want to go to sleep, and I mean certainly on these, this is a really cool way of actually demonstrating how algorithm can be applied in a really cool way, right?
Yeah, and it's a nice simple algorithm. It's not that hard, the concept. I mean, it only took me like a few days to make this.
Oh, that's very cool. It's like a university project. God help those university people. Come out of university and go, show us an algorithm, and they can't make a game.
Sure.
Anyway.
Sure, I'm quite happy with the result, actually.
Oh, we'll do some different colors then. Okay, cool.
Yep, you can burn your eyes with the hard, very strong blue color.
That is freaking awful, isn't it? Good gracious me.
I do wish when you coloured it in, it wouldn't be so voxely like coloured in, but
look, I mean,
I can't figure out how to fix that. But the actual digging part, it works brilliantly. You can mine bigger chunks out.
And this is just a demonstration of the algorithm. And that's
it's the most simple version of algorithm, no weights, nothing like that.
Okay, great. So are you going to explain the code now?
Yeah. I just want to show you just one last thing before I start with the coding. So I scroll through all this
Gosh, that mouse.
initialization
I must
code.
get you another mouse. That mouse should be like destroyed.
I know, it's the most loud damn mouse you've ever heard. But if I disable clearing the lines, it does look quite cool having
Oh wow, that
saying
looks
all the
really
lines.
cool. Wow, you should have started with that.
You can show all the little individual pieces. It's just quite cool though. You can see all the individual parts are made.
So you can imagine. I remember many years ago we used to have a game that someone would have a cave system and they'd swim through it perhaps, or they would mine through it or something. That's a very cool little game, like a.
I remember this one game.
Game.
I've forgotten who made it on YouTube. I think that it's the guy who made Fruit Ninjas or something. But he made a cool little swimming game. As a diver, you must swim down certain filled up caves. It's a very cool looking game.
Yeah.
But I don't know if he used marching squares. I think he did. I don't know if he removed it or I'm not sure. But it is quite a cool algorithm for any kind of cave or mining game.
Yeah.
Imagine swimming this little character or mining through it. It would be very cool.
Yeah, and then maybe little diamonds in certain areas where you can get.
Yeah, and it's very nice. You can have destructible worlds. You could have an explosion that blows up entire areas. It's all nice. You can even make physics-based things where things fall down or something. I'm not sure. But it is just, it's quite cool.
Anyway, cool. That's me gone. Go and talk about the code, the boring stuff.
Yes. Yep, the boring stuff you've all been waiting for. Right, so all the remaining people here still. Let's start with the coding. Okay, so I'm in my gamescene.swift file. So as you see here, we have the override func scene did load function. So this function is equivalent to the void start in Unity, and it runs only once, and well, that's about it. So in here, I'm just setting an offset, which is just getting the center of the screen. That isn't very important though. So here are the two most important functions in the entire game. The initialize map and the build map. So all the initialize map does is initialize a 2D array I have of integer 8s, or really just integers. And that's just, so 0 is, so if let's say we have our value as 0, the entire world is made of air. And to show you that, if we make it 0, the entire world's empty. If we made it 1, then I believe there'd be rock or something. And it's all rock. 2, I think it's dirt. And it's dirt. So as you see, this just loops through the entire array. And the reason why I'm not making using the, I've forgotten exactly what, there's a special function note built in Swift that allows you to easily initialize 2D arrays without having a for loop. The reason why I'm not using this is because before, I needed to make things like, I wanted to make things like uint8 random between, let's say, 2, 3. So I can have random blocks appear. So as you see, the whole world's completely random. It's all randomly generated using just random values. And I believe the function doesn't support this random no range. Although generally I'm not using the random. But that's about it for initialize map. So it sets a vertex grid, which is all the vertices. The reason why there's not an object grid for the objects is because you need the vertices, not the objects. So each vertice has 4 vertex, which change whether they exist or not. So if uint8 0, it's air, 1 and 1 above, it can be any, it starts indexing in your color map, which is just an array of colors or block types, I guess. So I was imagining the gray would be stone, brown would be dirt, blue would be water, orange would be lava. But you just have the index. So if it's 1, it's a gray. If it's 2, it's brown. If it's 3, it's blue. So on and so forth, for however many colors you have. But in the vertex grid, what I'm doing is, if we go to our build map, so the build map loops through the vertex grid, and it's looping through it except the very last index. And what it's doing is it's checking the 4 vertices. Hopefully I'll remember to add some graphic to the screen here. So I have 4 vertices, and it first checks what's the vertices. So I have a case array, just an array of cases up to 15. So 16 different cases for all the different little blocks. So each one of these blocks, so this little angle is a block, this little angle is a block, this little angle is a block. Each one of these is a big grid. It's 100 by 100, I believe, this grid. And this is all hundreds of little blocks. So what I'm doing is I have a quite clever system, which I didn't think up, by the way. It's quite a cool system though, so it's less laggy. Before I had a huge array of if statements, right? So what I did is I checked if there's a top left. If there's a top left vertex, is there a top right vertex, is there a bottom left vertex, and a bottom right vertex. This is all in the get case index at position, by the way, function. So I'm getting what case to choose. But here, what I'm doing is, instead of having an array of if statements now, like let's say if top left is equal to true and top right is equal to false, and having the whole list of all the different variations, I have quite a cool system where I have a binary number. I make a binary number. So the binary number looks a bit like this. If there's a top left, then the first digit becomes 1. If there's a top right, let's say there's no top right, there's a bottom left, then I make that, if there's no bottom left, I make that 0, let's say. If there's a bottom right, I make it 1. And that constructs a binary number. And this binary number, it converts into a decimal. So if I just search what 1001 is in decimal, then that becomes 9. So this is 9. And if that is all true, then it goes over to number 9 here. And I've ordered this, followed a really nice Wikipedia article, I'll link it in the description, but it explains I'm making the basic marching squares algorithm, not using the weights and all that, because that's a bit complicated. It's too complicated for me right now, but I have a list of vertices, and I just spawn it at that position. So you get what's in case indexes. Then what we do is we get the actual case from the value. Well, let's undo this, not break all my code. So if I scroll up, in build map we have a get case. And this get case, I input the index I got from get case index at position. Because here I'm getting a binary number, but I'm converting it to a integer, a normal integer again. So that converts the binary to decimal. And actually, one more thing I want to show you here. Quite a cool thing I learned, hopefully it will be useful to you one day. It's radix. So if you initialize a string, so I'm having an int and it inputs a string I made. But if I give as one of the parameters or arguments of the integer as radix, not sure exactly what it means, radix, but if you make a 2, input as radix is 2, it's not a necessary one, but it is for binary numbers, then converts the 1010, let's say, of a string into a proper binary number it can read. And it just converts it to a normal integer decimal number. Quite cool, useful thing though. But if you scroll up, go build map. Next, I'm just doing some non-essential things like getting the color. So I'm getting value at grid position. And get value at grid position, all it does is I just check, make sure it's within bounds. And it returns 0 if it's outside bounds. Or I give it the vertex grid at that position. And as I said, the vertex grid is generated along with initialize map. But if I scroll down, next I have a color. So I just check if the color index is, so there's a color index we're generating. So the color index is an index of my color map. So if it's 0, it becomes gray and rest of that. So I'll scroll down. The little thing I did is the reason why I minus it by 1 is because if we have that, it will just become it will have 1 for gray, because 0 is air, so I can't have it air, so I minus it by 1, minus the color index by 1 to get the color map. And that's then the color map, because it's an array, I just give it the index and it gives me the color. It's all quite nice there. Then I wish I didn't have to have this whole if statement. A bit irritating, but I can't really change that or fix that. Next, I add shape from points. I give it the points, which is the points I'm getting from the get case. It's a vertex array. And then I'm giving it the x and y. So this may seem incorrect, but it is y and x. That's correct. Now, for some reason, the whole world is rotated 90 degrees. Don't ask me why, and I can't seem to fix it. However, this does help a bit by rotating it 180 degrees, but it's still a bit broken. So I just changed my drawing system so you don't notice anything when drawing the whole sprite. When drawing your, so drawing would be just breaking blocks or placing blocks. So you never notice the difference. And it's just hidden, but it's just a weird... just weird in my code. I have no idea why that happens. Anyway, I give it then the color of the sprite, and I give it a thing called case ID. But most of the case ID is just some stuff to just anti-lag stuff mostly. So you don't need to worry about that too much. But it's just some stuff to make sure I don't have to regenerate the whole world multiple times. I only regenerate the parts that changed. And here it just checks the object, checks if it's the same, then there's no point in changing it. So I just return out here. But that really helped with lag. Before, when you're breaking blocks, it went to like 2 FPS. But now it's 60 or 50 at the very least the whole way through, which is great. But anyway, we have a shape points, which is our points array. And I just pinned the last points. So I pinned points index 0. And that's because in here, all these are made up of kind of different shapes. However, the first shape, right? The first shape I have to pin to the end to make sure it fills the shape in. So I'm just doing it automatically there, because it's just tiring to just add the same shape again and again. I mean, just add the same value again. It feels just a bit boring, because it was a mission writing all those. I had to write all those by hand. Okay, but there's probably some online place that has all these, but it wasn't that bad because there are only 16 different cases. But I had to rewrite it like 2 or 3 times. Anyway, we have shape node. I'm using an SK shape node for this because it can input points. And I think for rounded edges you could use spline points. And it just inputs a count, which I'm just giving it dot count. Then I'm placing it in the map. And I'm adding it to the world. I'm also setting its full color to the color value, NS color value we're inputting. And I'm setting a straight color to .clear. So I'll show you what that does if we remove that code. It's also a bit laggier because I have to draw hundreds of little lines. But here you can really see how the grid works. And if we start breaking it, it's actually quite cool looking, but it runs at like 22 FPS, so it isn't that great. But you can really see all the different shapes really individually. I actually quite like it with this setting on, but yeah, it's quite laggy. But well, it looks quite cool. So if we add the dot clear back, which removes a lot of the lag. And here just also some more stuff just because I have to have anti-lag systems. Just this is adding to a dictionary, the object. And here I'm checking the dictionary at that position. If it's the same, it doesn't matter. then we just return. But that's pretty much it with the whole marching squares algorithm. But it isn't very exciting unless you're able to break stuff. So as you see, I can break nice big chunks, maybe dug or something again. Or you can place stuff with varying colors. And that way too deep blue. So all that stuff is just quite average, nothing special. It's just getting a mouse down. I'm updating the grid when we click down. Updating the grid just regenerates the map pretty much, but it also has it with breaking it. So it gets a location with the event I'm giving it, which you get the event from mouse down. Gives it location a bit more data, but all I care about is location. And I changed the mouse position coordinates to grid coordinates, which is 0, 1, 2 in indexing. It's a bit of a irritating process converting it. It's quite a big function. So I won't show you that. It's just, it isn't that exciting. I'm just dividing a lot of things, timesing a lot of things, and tweaking a lot of very fine, minute values to get it all working. Bit of a hack. I don't like that function very much. But anyway, I'm just checking if it's within bounds, and I'm getting a X and Y offset, because I have if we open the key down, I actually have, you might have noticed, that I can break stuff. So here's the normal brush. We have a bigger brush, bigger, and then colossal. Why do you even need this brush? But it is quite cool, just to break everything. But anyway, you can, that's how I'm getting the brush size. I should really minus some values just to make sure it's in the center of the mouse, but it doesn't matter. And then I'm rebuilding the map here, which is the same function I used at the start. And here I'm just adding the brush sizes. So we have key, and that's Q. So I'm pressing Q button every time I want to change the setting value, which is the color map. And here I'm checking if we outside the, so I'm just scrolling through the color map pretty much, with of course the air, because air is number 0. So if we look here, the order is gray, brown, blue, orange, and of course air at the start. And if I just break it, so we have air, which is breaking it. Then I have stone. I have dirt, I have water, which is blue, and orange. And it's in the same order. And then it just scrolls back again, cycles back. And just does that forever. And here I'm doing a bit of a hacky approach of getting the brush size. So it has up to 4, but of course you can make this big as you want. It's nice and dynamic. But that's about it. So I hope you enjoyed it. Before I end the video, I just want to show you one little thing. So what I did is I have for my node data, which is some special data I'm using to check the map. It's just to make sure I don't place objects on top of each other, as I said earlier. I'm using a node data, which has a case ID and the node, SK node, which I'm giving over into my place objects and sprite. As you see here, I'm giving it the shape node. SK node is just a header for everything. For all the SK shape nodes and SpriteKit sprite nodes, all that. And then I have my custom vector 2. So there are lots of different vector 2 types, but none of them are hashable, I believe. So I made my own hashable. I needed hashable, and hashable allows you to add it to dictionaries. Before I couldn't do that. And I wanted an integer vector 2 as well. So it's more of a vector 2 int. But it doesn't really matter. So I hope you enjoyed this episode, and I'll see you next one. If you have any suggestions for any videos you want to see, then please comment down below, and I'll see you in the next video. Bye!